This is probably the one question I get asked more frequently than any other, which is to describe how an emotional reaction takes place or how it occurs. We'll have a quick reflection, first of all, on the structure of the brain. The brain at the back of your head is where your primitive brain is, and that's the most primitive part of the brain is sort of visualised this way. It's called the brain stem. The stem is the oldest part of the brain. It goes back to, if you think about it, to kind of prehistoric man, in that the early prehistoric man had what you might call a small head. They didn't have our size of forehead. So at the back of the brain is the stem, and in the stem really is that instinctive freeze, fight, flight. You've probably heard of that before. They're the three basic instincts of anybody: to freeze, stay where you are, don't do anything; flight, which is to run; or fight. And if you go back to caveman, if you look at yourself, then you will tend to have one of those three reactions, and obviously our ancestors had those same reactions. So that's the stem at the back. In the middle of the brain, in the middle of the head, is the hippocampus and thalamus. Now that's the computer processing bit, so that's the thinking bit of the brain. And at the front is what's called the prefrontal lobes, which are the emotional receptors of the brain. I don't think it's any coincidence that they're very close to the eyes and ears and at the front. And if you think that again would compare us to our primate forefathers, because they, you look at that old ape, if we do emanate from apes, and they tend to have a shallower front of head. They have when you look at them, an ape will typically not have such a well-formed front of the head. So that's the basic structure. You've got the stem, the hippocampus and thalamus, which is in the middle, and the temporal lobes, which is the bit at the front. And evidence has shown that this prefrontal lobe, I think they did some MRI scans on some young children in, I can't remember, part of the Eastern Bloc countries as the walls came down, and identified that the orphans in, I think, Romania or wherever it happened to be, had an underdeveloped prefrontal lobe because they hadn't received sufficient emotional stimulation. So this part of the brain was had been emotionally unused, and as a result, it's one of these things. The brain cells are all use it or lose it. Either you use this muscle in your head, or if you don't, it degrades and depreciates. I apologise for sunlight on the back window, by the way. It's a beautiful, beautiful day today, but I've decided to film now. So that's the basic construction of the brain. A couple of things more to remember are that just in front of the stem and underneath the hippocampus are two small almond-shaped components, I don't know what to call them, but bits of the brain, and that's called the amygdala. And the amygdala is the really, really, really important part of the emotional brain, because what the amygdala does is it stores your emotional memories. Now, go back in time. How many emotional memories have you had? It's immeasurable. Every day, every hour, every minute of every day, you're experiencing emotions. And you certainly have experienced emotions since you were first born, from the minute, in fact, from before you came out of the mother's womb. Inside the mother's womb, you probably experienced emotions in the form of sound and feeling and touch and so on and so forth. So what happens is all of that emotional memory is stored. Now, it's not stored in glorious Technicolor. What happens is it's stored, if you like, if you visualise it as photographs, it's stored as snapshots of memories. They're not especially crystal clear. What they are is they're likenesses, and they in effect get connected together. What they're there to do is they're there to work with your freeze, flight, fight instinct, which is your very basic human instinct. So the way the process works is an event happens. So there is what you call an emotional stimulus. It could be a horn blowing, it could be a fire alarm going off, it could be a partner shouting at you, it could be a boss sending you a nasty email, it could be any event. It could be and I think of events in this 6 ways. Events can be something you see, hear, touch, smell, taste, or feel. So if any inbound signal of sight, sound, smell, taste, touch, or sensory, or kinesthetic as the word is, any sense of any event, either isolated and individual or collective along with other ones, is a stimulus. It's an inbound activity. As that inbound thing comes towards you, what you get is two pathways in the brain. The first process goes from your point of entry, let's call it your eyes or ears, from point of entry to hippocampus, which is that bit of the computer processing bit in the middle of your brain. And it processes the logic of it. So it says the grass is green, the water's blue. If you walk past the seafront in Scarborough on a Wednesday afternoon, you look at the sea, you'll have probably little or no emotional reaction whatsoever. However, if you're walking past that same seafront and the storms are high and you've heard on the news the weather's going to be bad and there's red flags flying and there's people in sou'westers, and you walk past the point where perhaps somebody's not had a successful experience or perhaps lost a life as they have done on that beachfront, then what's going to happen then is you're going to have an emotional reaction. What happens then is, as the signal goes into your computer processing part of your brain in a nice controlled manner, it also sends it to your amygdala, and for all key events, it takes a snapshot of the event you're now facing, compares it with your entire past history of snapshots, and says, is there a similar emotional experience in my past? And if so, does it match the current scenario? So, if you've never had any problems at Scarborough Beach, then you're probably not going to find anything untoward. But let's bring that into a more sensitive context. If this is an argument with your partner, or a difference of opinion, or something that's mattered, or it's got an emotional charge to it, then what will happen is it will go to your amygdala, find a similar, and it will hijack your emotional circuitry. What that will then do is cause your freeze, fight, flight reaction. So you'll get a reaction rather than a considered response. So in a garbled kind of extended way of talking, what that means is when you see, hear, touch, smell, taste, or feel anything that is similar to, or very closely similar to, a previous experience of something, what the brain will do is it will go and grab that activity and the emotion attached to that activity and replay it here and now today. So that's what an emotional reaction is. It's a process of circuitry. It takes two neural paths through your brain. The first is your logically processed one, straight to your hippocampus. In parallel with that, it sends a signal to your amygdala. It says to the amygdala, have I been in this position before? Has this been a threatening, concerning, uncomfortable, emotionally charged experience? Yes or no? If yes, put me on freeze, fight, flight, which is why an emotional reaction can often be attached to one of those three really quite raw reactions, which is freeze. You know, you're having one of these emotional reactions with a certain partner, and you kind of go, just go silent, you just don't speak. Or they fight, so they come back with a volatile reaction, or they flight. I'm going, off I go, and they go and do what they want to do. So that's a quick and well, it's not so quick. It's an 8-minute assessment of what and how an emotional reaction is and how it works. So next time you see an almond, think about the amygdala. The word amygdala comes from the word almond comes from the Latin amygdala, and that's what your amygdala are. There's two of them, and they look just like almonds, same shape. Don't know what the texture is. Never eaten one. So there you go. That's my next video. Hope you've enjoyed it. Come back soon, and I'll talk about something else. Thank you.